Everyone knows the normal effects of beer consumption, but did you know that a dark chapter in brewing history involved a deadly additive? This unique element also powers everything from smartphones in our hands to the electric cars on our roads. This element has been known since ancient times and was first isolated in the 18th century. While it may not be as rare as some, its applications are diverse and vital to our daily lives. It transforms raw material into cutting-edge technology, making it indispensable in the fields of energy storage, aerospace, and medicine. Its atomic structure and properties allow it to play a vital role in modern electronics. But its journey from mine to market is fraught with challenges, including environmental and ethical concerns. Join us as we delve into the fascinating world of cobalt. Welcome to Cube Chemistry, where we'll discuss all the elements of the periodic table and also do experiments. And if you want to see more, make sure to subscribe. Cobalt is symbolized in the periodic table as Co. And with an atomic number of 27, meaning it has 27 protons and 27 electrons, and it has an atomic mass of 58.93. This metal has been known since ancient times. The name cobalt comes from the German word Cobalt, meaning goblin or evil spirit. Medieval miners gave it its name because it produced toxic fumes when it was melted and contaminated silver ores. Because cobalt ore looked similar to copper or silver ores, melting it often led to very unpleasant results. In 1735, the Swedish chemist Georg Brandt isolated cobalt for the first time. He was the first one to identify cobalt as a new metal and proved that it was the source of the blue color in glass and ceramics, a color that has been used since ancient times. So as you can see in this cube, cobalt is a shiny silver gray metal. It is also hard and belongs to the transition metals. It's ferromagnetic, meaning that it can become magnetized, a property that it shares with iron and nickel. It has a melting point of 1495 degrees Celsius and a boiling point of 2927 degrees Celsius. This makes it an essential element in various high-tech and industrial applications. However, be cautious. In large amount, cobalt can be toxic. Exposure to high concentrations can lead to health issues such as lung and skin irritations. So, what do we use it for? Well, cobalt is used in many ways. One of the most well-known applications is in rechargeable lithium-ion batteries. It provides stability and extends the battery's lifespan, making it indispensable in smartphones, laptops, and electrical vehicles. Cobalt is also used in superalloys that can withstand high temperatures and corrosion. These alloys are widely used in gas turbines and jet engines. For this reason, cobalt is often used in razor blades, in combination with elements like chromium and tungsten and carbon. Cobalt is frequently used for supermagnets, such as those made from samarium cobalt. In 1938, John Livingood, and yes, here he is again, Glenn T. Seaborg, discovered Cobalt-60. If you want to know more about Glenn T. Seaborg, make sure to look at the episode we made about seaborgium. Cobalt-60, a radioactive isotope, plays a crucial role in the medical field. It is used in radiotherapy for cancer treatment. Cobalt is also essential for life. It is a component of vitamin B12, which is necessary for the production of red blood cells and proper functioning of the nerve system. However, the extraction of cobalt is not without controversy. A significant portion of the world cobalt supply comes from the Democratic Republic of Congo, where mining is often associated with severe environmental and human rights issues. Efforts are being made to find sustainable and ethical sources of cobalt and develop alternatives to reduce the dependency on this metal. Cobalt is a versatile and indispensable element that plays a crucial role in modern technology and healthcare. But it also reminds us of the challenges associated with extracting and using natural resources. So, back to the question. Did you know that a dark chapter in brewing history involved cobalt? In the 1960s, beer drinkers in Quebec and Omaha experienced an unusual spike in heart disease, especially cardiomyopathy, a condition impairing the heart's ability to circulate blood effectively. Investigations revealed that breweries in these regions added cobalt sulfate to stabilize beer foam. They did this to compensate for poorly rinsed glasses. Cobalt, a metal used in alloy and necessary in small amounts for animal metabolism, can be toxic in high quantities. Excess cobalt interferes with cellular respiration and heart muscle function. Studies on guinea pigs showed diminished heart muscle contractions due to cobalt exposure. This explained the heart issues observed in beer drinkers. Interestingly, Montreal's larger beer breweries had separate batches for draft and bottled beer, with only draft beer containing cobalt sulfate. Smaller Quebec breweries used the same batch for both, exposing more beer drinkers to cobalt. This led to the term beer drinkers cardiomyopathy. Thankfully, cobalt sulfate was removed from the beer after these findings, ending this hazardous practice. Thank you for watching, and if you enjoyed this video, give it a thumbs up. And don't forget to subscribe to Cube Chemistry for more fascinating insights into the elements of the periodic table and exciting chemical experiments. See you next time!